So I'm going to try to do this video or audio and we'll see how it goes. Okay, so the use of rational numbers. This is just a basic slide to get you to think about rational numbers in a broad sense, because we're dealing mostly with what we usually call fractions in the elementary school, but rational numbers in the sense of dealing with proportions, ratios, and then eventually probability, which you'll do next time in Math 310. So this is just a basic slide to give you that information. Some of the basics that we looked at with the fraction models, what we did in class was folding the construction paper to make fraction strips. So remember that the basic idea, we start with a concrete model and then we use diagrams or drawings or pictorials, and then eventually you get to the abstract, which is where you use maybe a computation procedure, something like that. So one of the main ideas is the unit. You have to think about what is the whole unit that you're talking about when you talk about a fraction. If you want to know the value of a half, you have to know what is the unit that you're comparing it to, or that you're taking half of. So half of 10 is 5, but half of 12 is 6. So the unit whole, whatever it is you're looking at, is one of the main ideas. And then of course you have your numerator and your denominator. So the denominator basically tells you the equal portions that you're looking at, and then the numerator is how many of those portions. And we'll see that with the fraction strips also. So there's different models, and if you read in the book, you'd see the different models. One of them is the area model, and that usually means that you're using some kind of physical representation that has an area. So like this could be a square or a circle, rectangle, any kind of area. So this just gets you to thinking about, again, what is the unit? So this question says, is 1/4 greater than 1/3? Well, if you compare 1/4 and 1/3 just as fractions in terms of one whole, meaning the number 1, then 1/4 is smaller than a third. But in this case, right here, 1/4 is maybe larger than 1/3, or maybe they're almost the same size, but it depends on the unit. So this unit is this circle. This unit, we're assuming, is this entire square. And so when you compare this 1/4 to this 1/3, it really doesn't make sense in this case because we're not using the same unit. So when we make fraction strips or use pattern blocks or circle fractions or Cuisenaire rods, you want to make sure your unit or your whole is the same. Okay, the linear measurement model is really, again, using kind of like the bar diagrams and also the fraction strips that we did. Cuisenaire rods is another one. Any kind of linear model where you're drawing something like a line that could also include a number line. So we call that a linear model. So something like this. You have, this is your whole, this shaded part maybe represents the half. Or this is your whole, again, see the same unit. This whole from here to here is the same as this whole. They're the same size, they're equivalent. This one is divided into 6, so the portions are, there's 6 of them, so the denominator is 6. And 3 of these are what we're looking at. So this is kind of shaded to represent 3 out of 6 or 3/6. And you see it's equivalent to a half. I can maybe show a pointer here. Let me see if I can do that. It's not going to be great, but I'll try to show you with this pointer. So anyway, so we're seeing that these have the same length, and that's why it's called a linear or linear measurement model, because we're looking at length from here. It's not going to be great for me drawing like that, but anyway, so that is the showing you that 1/2 is equivalent to 3/6. So Okay, so I think I can get, all right, so a number line model, of course, uses a number line. And we can look at, how is it divided. This is actually more at a higher level. So you'll see this more later and outside of elementary school, maybe up in the, somewhat in the lower grade levels, but not this sophisticated. So this is kind of beyond, primary grades. And this also has negative numbers here, but just to show you the idea, and we'll look more with that later. So in this case, you're just shown some different values that are on the number line. Okay, the set model is when you, remember we had continuous, the area model and the linear model are continuous, and the set model is discrete, meaning that you can count things. So you might say, like, I have 10 apples, or there's 5 people in the class. So those persons represent the amount of people. We can discretely count these. So there's 10 apples, we can count them. And then we can say 3 out of 10 or 3/10 of the apples have worms. So maybe you circle the number of worms or something like that. That's a set model. And again, this is more difficult. Younger kids mostly have much easier time with the area model and the linear model somewhat. This is a little more difficult, and you have to think about things can't always be divided into an easy way with a set model. So we'll, again, hopefully that comes up a little later. Okay, so I'm hoping I can show you this. I'm going to pause. Okay, I'm going to try to do this. I don't know if it's going to work. I'm trying to show you, I think it's working, this online application, and I'm going to try to move this to hopefully show you the best I can. The National Council of Teachers of Math has a site called Illuminations. You can see right here. And it's pretty good. There's lots of different things that you can use on there. If you go to activities, you can search by grade level. So I usually click 3, 5, and 6 through 8, and then I search for different things. So one of the things that they have is what they call fraction models. So you can go to this site also and just explore some things here. So what we were just talking about was different models, and then also how you can show fraction in a different way. So this is kind of cool because you can move the numerator and denominator here, and then you can also change the model here. So first I'm going to leave it as kind of like a length or a linear model, which you can see right here. They're saying that's what it's called. So for example, this is showing, if you see here, numerator is 1, denominator is 4, because it's divided into 4 parts. So it's showing you this is the fraction 1/4. And then it also shows you here decimal equivalent and the percent equivalent, which is very nice. But what I really like about this particular one is we can move the denominator. So for example, let's start with 1/2, and this is kind of what we were trying to do with the fraction strips when we compared them. So first I'm going to leave the numerator as it is, but change the denominator. So you could have kids explore what happens. You can ask them particular questions. Maybe you could do this as a class activity. So 1/2, this whole shaded part is 1/2. Well, when I make the denominator 3, now I have to divide it into 3 equal portions. So the 1/3, the part that's 1/3, is smaller than my original 1/2. Then when I divide it into 4 parts, I get the fraction 1/4, and that changes it to 4 portions, or the denominator is 4. And you can see 1/4 is smaller than what we had originally, the 1/2 and the 1/3. And you can keep going. You can do it here, or I think you can use this. Oh, that was different. Okay, so I'm just going to move it. Yeah, you can use this button here, the plus button, instead of manually doing it here. So you could go to 1/5, and you can see that this portion that's showing the fraction is getting smaller. 1/6, 1/7, 1/8, 1/9. I think that's all it goes to. Oh, you could change the range. So see here, so now I can go up to 1/10. And what I really like about this is they can immediately see that if the numerator does not change, we can just compare denominators. So see how it keeps getting smaller, this portion. So when we go all the way up to, let's say, 23, I think that is. This is 1/23. That's a very small piece. That's very, very cool. The other thing is, I don't have a lot of time left here, but a region area, or it's kind of like the same thing as an area model. I'm going to move this back to bring this back down. So here's a circular example. So if we wanted, let's say we make the numerator, oops, didn't want to do that. I'm going to go back to the narrow range. So if I make my numerator, I might have to reset it. Let's say 3. I don't know why it's doing that. And then the denominator, let's say 6. Okay, then I can see there's 6 equal parts and 3 of those are shaded. So this time let's change the numerator. So let's say now we go to 4/6, and then I'll just click here, 5/6, and then 6/6, and you can see that 6/6 is equal to 1 whole. And the neat thing about this is if you keep going, you're going to have to show more than 1 whole, which is really nice. So when I get up to 7/6, you can see why it's 1 whole plus another 6. So 1 plus 1/6 is equal to 7/6. And of course you can keep doing this. You can just keep working on this and seeing how far it goes up. I guess at some point it's going to be hard to see these, but so we have 32/6. So why is that equal to 5 and 2/6? Well, it's because we have to make 32 of these little 6 if you're filling them in on this region, this circular region. So if you count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7, 8, 9, 30. That's 5 times 6. And then 31, 32. That's why we have 5 and 2/6. And then later you relate that to the decimals and the percent. I think what happens here is you can keep the running total, which is kind of cool. And I don't know if you can print it or not. I'm not sure. But anyway, I think that's kind of a really nice model. Not all the ones on this site are great. I mean, some of them are better than others. NCTM has a lot of good stuff. This is a really nice one, I think. So hopefully this works out and you guys will be able to hear me. We'll see how it goes.